Hey everyone, I hope y'all are having a great day. Today we'll be diving deep into the whole software as a service model, which has really transformed so many of our lives, but also created a whole new business model that has seen great success in the VC world today. And yeah, let's get right into it. So the biggest question most software as a service companies tried to answer is how do you design software systems that would be used by millions of people, and how do you provide value to those millions of people at the same time? So the biggest question here that really drove this whole software as a service ecosystem is like, how can I deliver a product or a service that can reach really everyone around the world? And how to reach everyone is typically to leverage some sort of connection that all of these people have. And in this case, it's the internet. The internet is a communication platform that has really spread its way to everyone. Of course, in a few geographical areas or lower income communities, we're still getting to that 100% number, but there's still a very high amount of people that have access to the internet, which is why it's such a desirable model to host some sort of service or product that provides value to everyone, just because you can get everyone to access it. So let's just get into the formal definition of what is software as a service. Software that is hosted by a third-party provider and delivered to customers over the internet as a service. Now, don't think too much about this formalized definition. What you should really be thinking about is some sort of application or service that's being hosted over some sort of network platform. So typically the internet that's providing value to someone. And the key for SaaS is that it's targeted primarily to people who are everyday internet users. So people like you and me who would be using this specifically to extract some sort of value, whether it's what music we're listening to, whether it's like a productivity solution, a communication platform. All of these examples are really providing us value, and they're hosted through the internet. And the internet is the key binder of all of these software as a service products because it lets us communicate with everyone in a method that all of us have access to. So let's just get into a few examples. Google is one of the most typical cited software as a service products because it's literally giving us a website which all of us can access. We can put in a few keywords and get results that provide us instant value in terms of what we're trying to learn more about. And of course, I'm just talking about Google search. Almost every one of Google's products is an example of a software as a service, such as Drive is letting you host different files, edit them, all via the internet. We can also look at Slack, for example, as a software as a service that lets us communicate with our coworkers via the internet once again. And well, Shopify and Spotify got kind of mixed into the same um, column entry here, but Spotify is letting us access our favorite music via the internet, and Shopify lets us sell our own products via the internet. So like I'm saying, via the internet, in each of these products, they're providing different kinds of value, but it's all through this channel that all of us can access. And I'm reiterating this point again and again because it's so important. So one really special thing about like people who are using software as a service is just how easy it is to use these products. So all you really need is like a mobile phone, a laptop, an iPad. It doesn't take too much computational power to use most services such as Spotify, Google Drive, Google Search, just because they're hosted mainly over the internet. The real backend work that's generating value is not being done by your own device, but rather you're just sending them inputs and receiving outputs that don't require that much expensive hardware, which is why it's so desirable and it's so scalable as well, because you can reach a really wide audience versus like if you were a game developer that built a native game, you probably need your users to have some sort of crazy GPU, crazy CPU to be able to run all of that software because all of the logic is being done on your computer, not via the internet. So once again, internet is coming key right here. So because the data is delivered via the internet, you don't need too many computational resources as the end user. So one thing that's probably going to be thrown around quite a bit in the whole as a service triangle that you see right here is there's software as a service at the very top right here. Below that is platform as a service. and below that is infrastructure as a service. So let's start out from the very bottom, and it kind of trickles its way up to the top to software as a service. So to run any sort of application that runs business logic or whatever you're doing, if you're coding, you're going to need a computer to run it on. And that's the whole premise of infrastructure as a service. If you're running some sort of application or you've written code, you need to have some sort of server, which is just a glorified computer that's typically a bit more powerful. A networking stack that lets you connect to the internet and send over that data from that computer to whatever other computers are trying to reach that website, for example. And to have all of those resources, you'll also need CPU, storage, memory, which will just help you run those lines of code in a fast and efficient manner. So to do that, it could get very expensive if you're doing a lot of data storage or a lot of computations, which is why this whole infrastructure as a service really got released. So basically, these are like things like Google Cloud, Microsoft Azure, Amazon AWS. So these are all services that are cloud offerings. And what they let you do is they let you effectively rent their computers, rent their data centers, and rent their networking stacks, just so you can get all of that power for a much cheaper price. And the key is you pay as you use. So you don't need to do that huge initial capital investment to buy these servers, but rather if you're only getting one user like every other day, for example, you'll only pay for that much time that they're using it, which is really nice for people bootstrapping startups and don't have that initial capital, and de-risks the whole process, because only as much success and usage as you get is what you're paying for. However, if you do use infrastructure as a service, you still need to know how to connect all the CPUs, the computers, the networking components, as well as whatever distributed systems you have set up, and make them all work together. And even I don't really know how that works at the deep level, and which is why this whole platform as a service got launched. So infrastructure as a service is still very difficult to use, but it allows you a lot of customizability in terms of how you want to launch your product. Now, platform as a service basically builds upon infrastructure as a service, except makes it much easier to use. So for example, with platform as a service, you can maybe just have like one sort of text box where you could type up all your code. So you're still having to code and write up your own logic, but when it comes to deploying it to the right servers, identifying like if someone is like reaching my website, which server should I use to compute the logic that they're asking us for, that sort of stuff is just abstracted away from us. So this is effectively designed for software developers because they'll be writing the core business logic, the code that's going to be doing the decisions for the website that they're building. However, they don't have to worry about how do I connect these computers and make it all work as a cohesive whole. So don't worry too much about platform as a service, as it's targeted towards software developers, and infrastructure as a service is targeted towards IT administrators. What we're really focusing on here is software as a service. So this is what the people using either PaaS or IaaS build. Once they build their website or their application, it's going to be used by end users. Like at the end of the day, we want to provide the everyday consumer some sort of valuable experience. And that product is going to be called software as a service. And I know this got kind of confusing, so let's just give a quick example. So an example here is going to be Slack. So for example, they'll use Amazon AWS to actually host their computers, which are running their core logic, and they'll use some more tools built by Amazon that helps them distribute the load. So like if 500 users are sending a message right now, which computer should we use to actually send that message to everyone and run the business logic? So that's being done by the platform as a service that the software developers kind of work with. And then finally, the end product is Slack itself. So the people using Slack are going to be the daily people at work who are sending messages to each other and trying to get work done by themselves. So this is used by end users. This is used by software developers at Slack. And this is used by IT administrators at Slack. And the reason why we want to focus on software as a service for this is because it has such a wide range of audience. So you can get a lot of paying customers who can get a lot of value from your product. So let's just get right into it. What's the formula for a successful SaaS company? Number one, right here, we say ARR N. So that's basically how much annual recurring revenue do you have? Annual recurring revenue is typically done through some sort of subscription service or contract service, such that, for example, Netflix, you're paying, I don't know what the price is right now, but you're paying monthly, and it's pretty guaranteed that Netflix will get this money down since you're a subscribed customer. And it's very easy to calculate your revenue. You just multiply however many subscribed customers you have by the cost. And if you want to multiply by a year, you multiply by 12. So it's very predictable, which is great because that's why it's really, I wouldn't say easy to evaluate software as a service companies, but you get a clear idea of how much revenue they're going to make and have been making. And this end subscript is kind of talking about the last year or this year if we're trying to plan the future year. And then we add up the ACV, which is the revenue gained from new subscribers or upgrades. So people either subscribing to a more premium plan or just new customers in general. And the goal is here just like how much extra annual recurring revenue are we going to get because of our new users? And churn is the people who either downgraded their services or just aren't paying the full subscription anymore. So it's a pretty commonsensical formula in that we're just seeing like how many people are already paying, how many people are paying more now, how many people are paying less. And logically, you want a higher ACV and less churn. Now, how do you increase your ACV and minimize churn is the question every SaaS company is really always asking each other, or not each other, but they're asking themselves. So let's try to figure out that formula. So number one, and is always the most important thing, you'll hear product managers and software engineers always asking themselves this question is, how do I build the best product possible for my end user? Because the end user is going to pay if they like the product. It's as simple as that. So the things you typically do is like interview your users, try to understand how much do they like your product, what could go better, what are they liking? So you can build upon the things that they like and reduce as much as what they don't like as possible, as well as come up with a few innovative features through your own vision that you think people will like and just validate whether they're liking that or not. And a typical way to kind of build for the user is just to make sure that your service is as fast, reliable, intuitive, and beautiful is just kind of a bonus if it's consumer facing as possible, because those are typically the formula that you use to build a nice product that everyone likes. Now, another big thing is like if you want people to use your product, you also have to pick your user base correctly. Because maybe suppose if you build Slack for a bunch of teenagers, the UI won't be as intuitive. It won't be as useful as someone who is maybe a employee at a company, because this is very work driven and created for people at the workplace. So if you're building a product, always think about who would extract the most value from your product and market to them specifically, because that's how you maximize that ACV. That's how you generate that growth. And if you want to expand to a new user segment that maybe will have a lot more higher user base, then change the features or create like a complementary product that would help you get that user base. And finally, like the simple thing that everyone like hates is when your product goes down or stops working. That's like a very obvious mistake that all devs strive to minimize. So keep your product up and running as long as possible and minimize as many bugs, which are basically unexpected behaviors or errors, as possible. So let's just talk about a basic software as a service architecture. And I'm going to talk about websites specifically to keep things simple, but this could really be a cross apply to a lot of mobile apps as well as desktop apps, as long as they're communicating via the internet. So we start out here at the left with the users. The users are using their mouse or their keyboard to interact with some sort of service, maybe even their voice and their video, but whatever they're doing, they're sending some sort of inputs to something called a front end. And a front end is whatever you're interacting with. So typically in a website, it's going to be through some sort of browser like Chrome, Firefox, or Safari. And you'll see like a window, a UI, and that's called the front end, whatever you're using your mouse on, whatever you're typing on. It's also known as a client, front end, or just a browser. So those are some buzzwords that are thrown around, but at the end of the day, let's just call it a front end. And this is coded in 3 primary languages, HTML, CSS, and JavaScript. HTML is the building blocks of the elements you see. So if there's a title, that's going to be typically like a block that's saying, okay, this is a title, make it this big. And CSS is all the styling. So it's going to be like the colors that are being displayed, the animations, as well as just what shapes everything is, what fonts they are. So all the design aspects. And JavaScript is going to be all of the interactive elements and the core business logic. So if you click on something, what happens after that? That's all JavaScript. Or if a user scrolls too fast or does something that's very interactive with whatever window you have, it's going to be run by the JavaScript. So just to reiterate, HTML building blocks of the website, CSS is all of the style, and JavaScript is all of the interactive logic. So whenever you do interact with something, suppose a button, it'll call some JavaScript code probably. And what the JavaScript code will typically do is call a request. And this is also known as an API request. And what this effectively is just a block of data. So it could be things like if you're registering for a new user account, it'll send over your username, your password, as well as some other identifying information like your name, your profile picture, and extra. And this is typically things that are more sensitive data that we don't want our user to really be like having to worry about. Or if we're doing something computationally intensive, we'll send over that data and let the backend handle it. So let's go into what the backend is. So this whole right part is really called the backend. It's composed of your core app logic. So for example, if we're doing something intensive like editing a video, what we would do is the front end would send in the coordinates of when you're starting and ending the video if you're just cropping it. So for example, if we only want the first minute through the fifth minute, we're going to be sending over an API request that says start at the first minute, end at the fifth minute, and what video are we actually editing. Then this app logic will probably do some sort of downloading of that video, actually physically editing it to be smaller, as well as uploading it again. And once that's all done, it'll send over a response. And this response will probably have the URL of the new edited video so the user can download this in the future. So one thing that you might have noticed is whatever happened in the front end was pretty computationally chill. Like all we're doing is calculating two different numbers and sending it over via the internet. Nothing crazy if the actual editing happened on the front end. That all happened in the back end. And the reason we want the back end to do all of the computationally intensive stuff is because we have control over what kind of processors, RAM, all the computational power is in our control with the backend because we're the ones who decide what computers are being used for that. For the front end, we don't know. Like someone could be using a 20-year-old computer to access our website, which is why we don't want to overwhelm them, unless of course that is your goal, like you're building some sort of web game or something, but that's aside from the point. So once again, just to reiterate, this whole request response kind of infrastructure is really key for websites. You're sending over data, your backend is doing some sort of calculations typically, and it sends over the end result of those calculations back to the front end. And it's kind of like a back and forth that just keeps going on. One thing is the backend can be connected to even more backends if they want. I don't want to get too much into that, but one thing that they are typically connected to is a database or a file system. And what these are just very like robust systems that just store data. And they're designed so that lots of people can access this data at the same time. And the data is very reliable. So it won't just like magically disappear. It's a very like sturdy database that's designed to be used by lots of backends at once. And we'll get a little bit more into depth, but let's just go into like what the whole process of like editing a video might be. So suppose I've created a website called videoeditor.com. What I'll do is I'll type that in the web browser. Once I hit enter, it's gonna, Google Chrome, for example, will go to this thing called the DNS, search for videoediting.com in this DNS. And what the DNS is it's basically just a list that has a bunch of websites, And for each website, it's pointing to an IP address, which is effectively like a phone number for a computer. So think of it like a phone book for all websites. It returns the IP address back to the web browser. And this IP address is, like I said, a direct point to the server that you're trying to hit. So once you get this IP address, you'll get all of the HTML, CSS, JavaScript code that you need to run on your browser, and you'll start to see the actual website. And once you're able to see everything, then you start interacting with everything. And suppose you click a few buttons, you enter some forms, that's going to have that whole HTML request and response framework that we were talking about. So in the video editing example, suppose we drag a slider that says it's going to be 1 minute to 4 minutes. We're going to drag that slider, hit submit, and then what's going to be sent over in the request is going to be the 1, the 5, as well as like the URL for the video that they're editing. Now this is the web server. The web server will basically just kind of tie you to some sort of backend, which is just a computer running the code that we've written to actually edit the video software. And once it decides which backend we want to go to, we'll go there and actually do the video editing process. Like I said, download the video, edit it, and re-upload it. And once we're done, we might also want to save that to the database just in case they want to check their previously edited videos. And once we're done with that, it just goes back to the web server and goes back to the browser via HTTP response. And one thing that I just want to clarify is you're going to see the words HTTP a lot. That's just another name for APIs. HTTP is a web standard that you use for websites. There's a lot more web standards that we can learn in the future. But for now, just think of it as just a framework for sending requests and responses. So I'm going to go over this demo in another video, just a more detailed example, and I'll send that right after this. Same for the backend demo. But let's just go over a bit deeper what a backend really is. So like I said before, it's just a computer that's running code that we've already written. And it's listening for requests. And whenever we get a request, it's going to run a few lines of code that's been pre-written. And once we're done, it's going to send over a response back to the web browser. So you can write this backend in effectively every computer language that you want. The most popular ones are typically Python, Java, and JavaScript. If you want like really fast response times, you'll typically use something like C or C++. If you want something that can be written really quickly but might run a bit slower, Python's probably one of the easiest languages to get started with. And just an example of why all languages end up working is these are called high-level languages because they're typically written closer to the English language than what you would expect a computer to understand. So lots of words are shared with the English language. So programmers can actually type up these programs and understand what's going on at a logical level. After that, we've written a few things called compilers that will turn that language into assembly language, something that's much more difficult to understand, but much easier for the computer to understand. And assembly language is then converted by the computer into machine code, which is effectively, just think of it as a bunch of zeros and ones, and that's read by the hardware as logic. So you can go from things that are written pretty close to English to zeros and ones, which I think is a really cool thing. And that's how computers are able to interact with engineers in general. You write code, turn them into zeros and ones, and then the computer basically registers these instructions and do what you want. And that's why you can really use any language you want because they each have different compilers to compile into different kinds of assembly. So I'll once again have another video where I go over different demos. Let's just dive a bit deeper into like APIs and HTTP because I know that might be a bit confusing. So API is just a communication platform between your web browser or the front end and the back end. So the way it works is it's just a framework that's just like the internet. So whenever you're sending API requests, you have to have a URL while sending that. That's basically going to be the address of whatever your backend is being hosted on. And once you've actually sent that request, it's going to go to that actual backend, run some sort of application logic, and once that's done, send that result back over to the front end. So API is just like the control plane that's controlling the request and response cycle. It's just kind of like a roller coaster back and forth. And the typical requests are in the HTTP standard that we talked about before was get, post, update. And get is just if you're trying to get some information, you use a get request. If you're trying to send and save some information to maybe like a database, you'll do a post request. And if you're trying to update information in a database, you'll do an update request. And the names are pretty logical. You can learn more about these in specific, but all you need to know is HTTP is that communication layer that lets the front end to find an appropriate backend and send over data and receive data back. So before we go into what's next, I just really wanted to summarize that there were a lot of new words that you might have heard today. Don't worry too much. All you really need to understand today is that we have this amazing platform, the internet, that lets all of us who have internet access different URLs. And these URLs are all tied to front ends, which let us see a nice UI, interact with it. And while we're interacting with it, we can use things called APIs that connect us to a backend. And then the backend does a lot of hard processor intensive tasks that we can't typically do with our own computers or typically require accessing a database that we don't have access to. And once we're done with all of that processing, we send over that data back to our front end and get value from it. So one key thing to remember is it's just a series of inputs and outputs. You're putting inputs to your computer, those inputs are being sent to the front end. The front end might send some different inputs to the back end. The back end will take those inputs, do some sort of magic to it, send over an output. Output will go to our front end and give us value. So once you understand that it's just a game of inputs and outputs, everything gets radically simplified and you can really start having fun with what you're trying to build. So what's next? If this is a relatively easy concept, why is it so hard for companies to succeed? A huge thing is like scaling. When you're trying to build systems, it's very difficult that if like hundreds of people are, for example, trying to create a Google Doc at the same time, your backend might get a bit overloaded because you're doing API requests, maybe saying, save this Google document, and it'll all be routed to the same computer if you only have one backend server running. But the trick is like, why not have like 5 backend servers running or 10 backend servers running? And then the hard part is like, how do I tell which front end to tie to which backend? And how do I handle that sort of load if I get too many users? Do I make them wait? Do I just tell them that we're busy right now? It's a very difficult problem. And it's even more difficult when we're doing things like real-time collaboration, just because if 2 people say one thing at the same time, how do you decide which one goes first? What if someone overwrites another person's changes? So it gets very tricky very fast, which is why it's really important to be thinking about all these problems at a very technical level. But that's a very future thing and something that many companies still struggle with. Another thing is analytics. Analytics are really important to us, and especially product managers to identify like how good is our service doing. So a very common analytic is just like how many total users do I have? How often are they reusing the service? Like, are they coming back? Are they truly liking our product? And you can also have different analytics that zoom into maybe like different buttons, like how often is this button click? How long does it take for this button click to actually like show something of value to the user? So you're just measuring different tasks, understanding like how good the user experience is without having to interview every single one of your users and ask them yourself. So it's effectively like an automatic data collection that understands how good your product is. Finally, CI/CD, which is continuous integration, continuous development. This basically just means like if I'm writing code, my friend is writing code, my other coworker is writing code. You got all these people writing code at the same time, and if you want to push it to production, which is effectively meaning like you're deploying it to the internet for everyone to see, you have to make it a very smooth process because if I push something, we don't want the service to just go down for everyone for like a solid 2 minutes. Imagine if every time Netflix like pushed a new feature, everyone's show would just stop watching for 5 minutes, or even something very critical like Google search, which is why it's very important to like slowly ease off people from the old version to the new version without messing up their previous experiences. And this is actually a really big reason things do go down, is if they mess this part up, which is very easy to do. So I know this was a lot of content. If you guys have any questions, or if I kind of like went over something quickly, please send a message over to me on Slack. I'd be more than willing to get on a call with you, explain a few more concepts, and also show a few more examples. This was a fully conceptual presentation. I'll be sending over another presentation that kind of goes over a real life example that I've built, and show you what it really means to send over API requests, the whole request and response cycle. And yeah, I hope y'all will enjoy that. Hope y'all learned a lot, and I hope y'all have a great weekend. Thank you so much.